Long-range air defense is one of the most critical elements of modern military strategy. In today's battlefield, threats can appear from hundreds of kilometers away in the form of aircraft, cruise missiles, ballistic missiles, and even advanced drones. Nations invest billions of dollars to ensure that their skies remain protected. Long-range air defense systems act as a shield, detecting and destroying hostile threats long before they reach strategic cities, military bases, or critical infrastructure. To understand long-range air defense, imagine a protective dome that constantly scans the skies. This dome is created by a network of radars, command centers, and missile launchers working together in perfect coordination. The goal is simple: detect incoming threats as early as possible, track them accurately, and intercept them before they can cause damage. Unlike short-range systems that protect a small area, long-range systems are designed to cover vast regions, sometimes hundreds of kilometers in radius. The first step in any long-range air defense system is detection. Powerful radar systems continuously sweep the sky, looking for any object that could pose a threat. These radars can detect aircraft or missiles from extremely long distances, often more than 300 kilometers away. Modern radars use advanced technology to distinguish between friendly aircraft, civilian planes, and potential enemy targets. They analyze speed, altitude, flight path, and radar signature to determine whether the object should be considered a threat. Once a potential threat is detected, the system moves to the tracking phase. Tracking radars lock onto the target and continuously monitor its movement. At this stage, the system calculates the speed, direction, and altitude of the incoming object. Sophisticated computer systems process this information in real time and predict the target's future path. This allows the air defense system to determine the best moment and position to launch an interception. The command and control center acts as the brain of the entire air defense network. Here, highly trained operators and advanced computer systems analyze radar data and decide how to respond. In modern systems, much of this process is automated. Artificial intelligence and advanced algorithms help identify threats and recommend interception strategies within seconds. However, human operators remain responsible for authorizing missile launches and managing the overall defense response. Once the threat has been confirmed, interceptor missiles are launched. These missiles are specifically designed to travel at extremely high speeds, often several times faster than the speed of sound. Their mission is to intercept and destroy the incoming threat before it reaches its target. Some interceptor missiles use proximity fuses that detonate when they come close to the target, while others use direct hit technology known as hit-to-kill, where the interceptor physically collides with the target at high velocity. Long-range air defense systems are designed to counter a wide variety of aerial threats. Fighter jets and bombers are among the traditional targets. These aircraft can carry bombs or missiles capable of causing massive damage. By intercepting them from long distances, air defense systems prevent them from reaching their attack range. Cruise missiles are another major threat. These missiles fly at low altitudes and follow complex flight paths to avoid radar detection. Because of their small size and ability to maneuver, they are extremely challenging to intercept. Modern air defense systems use advanced radar technologies and networked sensors to detect cruise missiles even when they attempt to hide behind terrain or approach from unexpected directions. Ballistic missiles represent one of the most dangerous threats in modern warfare. Unlike cruise missiles, ballistic missiles travel at extremely high speeds and can reach targets thousands of kilometers away. Intercepting them requires specialized long-range defense systems capable of tracking objects traveling at hypersonic speeds. These systems must calculate the missile's trajectory and launch interceptors within seconds to successfully destroy the threat. Another emerging challenge for air defense systems is the rapid growth of unmanned aerial vehicles, commonly known as drones. While drones may seem small compared to aircraft or missiles, they can be used in large numbers to overwhelm defenses. Advanced long-range systems now integrate specialized sensors and interception methods to detect and neutralize drone swarms before they reach protected areas. One of the key advantages of long-range air defense is layered protection. Modern militaries rarely rely on a single defense system. Instead, they create multiple layers of protection using long-range, medium-range, and short-range air defense systems. The long-range systems intercept threats at great distances, while medium and short-range systems provide additional protection closer to the target area. This layered approach significantly increases the chances of destroying incoming threats. Mobility is another important feature of modern air defense systems. Many systems are mounted on large military vehicles that can quickly relocate to new positions. This mobility makes it difficult for enemy forces to target and destroy them. In addition, mobile systems allow commanders to reposition air defenses depending on the location of potential threats. Networking and integration have also transformed the way air defense operates. In the past, individual radar systems and missile batteries often operated independently. Today, modern systems are connected through secure communication networks that allow them to share information instantly. A radar in one location can detect a target and pass the data to a missile battery hundreds of kilometers away. This networked approach greatly expands the defensive coverage and improves reaction time. Long-range air defense systems are also designed with redundancy and resilience in mind. Military planners understand that in a real conflict, communication networks and radar systems may be targeted by enemy attacks. To address this, modern air defense networks include multiple radar stations, backup command centers, and alternative communication channels. Even if one part of the network is disabled, the rest of the system can continue operating. Training and coordination are just as important as technology. Operating long-range air defense systems requires highly skilled personnel who understand both the equipment and the complex tactics involved in aerial warfare. Operators must be able to identify threats quickly, manage multiple targets simultaneously, and make critical decisions under intense pressure. Regular training exercises ensure that crews remain prepared to respond effectively in real-world situations. Throughout history, air defense technology has evolved alongside advances in aviation and missile technology. Early air defense systems relied on anti-aircraft guns that fired explosive shells into the sky. While effective against slower aircraft, these weapons had limited range and accuracy. As aircraft became faster and more advanced, missile-based defense systems were developed to provide greater reach and precision. Today's long-range air defense systems represent the result of decades of technological progress. They combine powerful radar sensors, high-speed interceptor missiles, advanced computing systems, and secure communication networks. Together, these components create a defensive shield capable of protecting entire regions from aerial threats. However, the development of air defense technology never truly stops. New challenges continue to emerge as military technology advances. Hypersonic weapons, for example, travel at speeds exceeding 5 times the speed of sound and can maneuver unpredictably during flight. These characteristics make them extremely difficult to detect and intercept. As a result, researchers and defense engineers around the world are working on next-generation air defense technologies capable of countering these advanced threats. Electronic warfare is another factor that influences modern air defense systems. Adversaries may attempt to jam radar signals, disrupt communication networks, or deceive sensors using advanced electronic techniques. To counter these threats, modern systems are designed with sophisticated electronic countermeasures that allow them to operate even in heavily contested electromagnetic environments. Ultimately, long-range air defense plays a vital role in maintaining national security. It protects cities, military bases, power plants, and other critical infrastructure from aerial attack. By intercepting threats far from their targets, these systems provide valuable time for governments and military forces to respond to potential conflicts. In many ways, long-range air defense represents the invisible shield that guards a nation's skies. While most people rarely think about these systems during their daily lives, they operate continuously in the background, scanning the horizon and preparing to defend against any potential threat. Their presence acts not only as a defensive measure but also as a powerful deterrent, signaling to potential adversaries that any attempt to attack from the air will face a strong and capable response. As military technology continues to evolve, long-range air defense systems will remain a cornerstone of modern defense strategies. Their ability to detect, track, and intercept threats across vast distances ensures that nations can protect their airspace and maintain strategic stability in an increasingly complex security environment.